we've already talked about hydrating alkenes. And the way we did that before, which is a completely valid way to do it, is we treat this with water and maybe something like sulfuric acid. You could use phosphoric acid. And as you did this, you would get this alcohol as a product. It's a Markovnikov alcohol, went through the more highly substituted carbocation. So this is a carbocation pathway. And because it's a carbocation pathway, we get the Markovnikov product. Fantastic. Okay, I'm going to show you another mixture of reagents that people will use. People will treat an alkene with a reagent called BH3, that's borane. And then they'll, as a second step, they'll treat this with sodium hydroxide, hydrogen peroxide, and water. So that's quite the mixture, but when you do these two steps in this order upon an alkene, what you get is this product. Now this product is the anti-Markovnikov product. And I'll put exclamation points because that's kind of interesting. We get the opposite regioisomer than that we did with the simple acid and water chemistry. Because it's anti-Markovnikov, that gives us a clue to how this reaction occurs. There is no carbocation in this reaction. If there were carbocations, we'd see the Markovnikov product. So this gives us a hint that there's something else going on. Now, I'm not big on the mechanism for this reaction. I think it's an important mechanism, but the fact is, for this class, I only like to emphasize mechanisms that show up in multiple different places. And the fact is, this is just an isolated mechanism, so we're not going to learn this mechanism. However, we can walk through the steps. The first step is to react this molecule with BH3. This is called a hydroboration. In the hydroboration, we're going to add H to one side of the alkene and BH2 to the other. And as it turns out, when you look at this molecule, H and BH2, this is kind of the big end. When we look at our alkene, and we think our alkene as one half or the other, this is the bigger side of the alkene. So when we bring these two reagents, the big ends, sterically push against each other, and they go to opposite sides. So once we do the addition, we're not showing the mechanism, we're going to add the H, which is the little end of the BH3, to the big end of our alkene. And that puts the BH2 over here. This is a hydroboration. We've added H and BH2 to our molecule. That's the end of the first step. So the second step, we treat this with sodium hydroxide, H2O2, and water. And now we go through the mechanism of, we're not going to go through the mechanism, but that transforms the BH2 into an OH group. And we get our alcohol. So this is an oxidation step. This overall process is referred to as, let's try to write that properly, hydroboration oxidation. That's what you would call this reaction. What is the net effect of the hydroboration oxidation? Well, we've added water. Therefore, the overall net effect is we've done a hydration. Now, we've done a hydration not by adding acid and water, but by using this set of reagents, BH3 and sodium hydroxide, peroxide, etc. Now, the great thing about that is we get the anti-Markovnikov product. There are times when you want to get the anti-Markovnikov product, but you can't. So here now we have an option. If we want to make the anti-Markovnikov alcohol, we can do that. Or, of course, we can use acid and water and get the Markovnikov product. So this is a way we use multiple ways to perform reactions, because sometimes we can coax them into getting different products. In this case, different regioisomers of our alcohol product.